The Flint River in southwest Georgia, home to rare Gulf sturgeon, tiger salamanders, Barber's map turtles, and more common species like alligators and striped bass. The Flint starts near Atlanta and flows south into Alabama and Florida. It's at the center of a legal battle over how these states will share its water, now at critically low levels.
We need to be looking after our river. There's nobody doing that now.
Georgia's farmers water their cotton and peanut fields with center pivot irrigation systems. From the air, they look like giant circles. From the ground, the pipes and sprinklers march slowly across a field, spraying water as they go. This method puts a lot of water on the ground and is widely used all over the world. But researchers at the University of Georgia came up with something better, a much more efficient variable rate irrigation system that tells a farmer when and where to water.
A critical issue for farmers is knowing how much moisture is in the ground, how much moisture their crops need, and how often they need to irrigate to maximize their crop yields.
A 5-year pilot project directed by the Nature Conservancy here saved 10 billion gallons of water, enough to supply a city the size of Orlando for a year. Moisture probes are sunk in the ground, and a computer records the data.
So we get some spikes when we have rain events or we have irrigation events. And then as it drops, we're drying out over time. You can choose anywhere from 0%, normal percentage, up to 200%. And then we can click with our mouse.
The color of each block represents how much water it will get. A 40-acre field has about 900 blocks, and each could have its own set of watering instructions. When the farmer comes to his field, he inserts a flashcard with instructions to run the motors, pumps, and nozzles of his irrigation equipment. Wet land gets less water, drier ground gets more. Conservation land for quail habitat doesn't get any at all.
Using the variable rate irrigation in the computer models, when we make one circle around this field, we save 600,000 gallons of water every time we go around.
To use this technology on a large scale, a wireless network will cover a rural area the size of Delaware, getting data and live pictures from their fields in a flash.
It saves on water, it saves on energy. They have the ability to log in with that camera and see, 150 miles of fields without ever leaving the house.
In 3 years, farmers could save 40 billion gallons a year here, leaving much more water flowing in the Flint River. For This American Land, I'm Gary Stryker.